This is Pre-Calc section 5.4 on logarithm functions. What we have on this first problem is an exponential function that is graphed, and I've already written the ordered pairs right there. And the reason I've written the ordered pairs is you're being asked to sketch the graph of the inverse. You should remember that you can get the inverse of any function by just switching your x and your y. So this ordered pair is now 1/5, -1. This is 1, 0, and this is 5, 1. I hope you also remember that the logarithm function is the inverse of the exponential function, and that's why we are graphing this inverse right here. So taking these red points, I'm going to graph them down here. Now pay attention to the increments here. Since this is 2, this right here is just 1. And to graph 1/5, -1, 1/5 is just barely over here. Down 1 puts it about right here. Over 1, 0 is right there. And over 5, see I had to extend my graph a little bit, 3, 4, 5, 1 is about right there, and then I'll try to connect this, and this is going to run right along the x-axis right there. So the red is the inverse of the blue. The red is a logarithm function. Now we want to find the domain, range, and increasing, decreasing in the equation of the vertical asymptote for the inverse. We're looking at the red. Domain of your red, going from left to right, your domain is from 0 to infinity, and your range is from -infinity to infinity. This inverse is increasing from left to right. Everything is increasing. And we want the equation of the vertical asymptote. Well, the vertical asymptote is the y-axis, which is the line x equals 0. A lot of the rest of this lesson deals with the domain, to find the domain of the logarithm function. We did this in college algebra, and remember the argument, I'm using the word argument, the argument is this part right here. That's an important word. When you want to find the domain of a logarithm function, all you have to do is set the argument greater than 0 and solve. Now in college algebra we did easy ones like this, x minus 1 greater than 0. No matter what the base is, whether it's log base 2, log base 10, or natural log, all we have to do is set the argument greater than 0 and solve. So this is simple to solve. Add 1 to both sides. We have x greater than 1, and our interval notation for that is 1, infinity. This one is just as easy, but you just got to be careful. This -1 out here is not part of the argument. The argument is only this part right here. All I have to do is set x greater than 0. Interval notation on that is 0 to infinity. This one, you might look at this and think, hey, absolute value is always positive, so it's just all real numbers, but it is not. Remember, you cannot take the log of 0. If 0 right in here, we can't have that number. So 0 is the only number that needs to be tossed out. So this is all real numbers except 0. So that would be -infinity to 0, union 0 to infinity. Now we get into ones that are going to require a little bit more work. They're not simple linear inequalities. It is still a matter of taking the argument and set it up greater than 0. But remember, to solve a quadratic inequality, we have multiple steps here. First off, we pretend that it is equal, and we factor this. We just pretend that this is equal 0. And we get these two solutions. We get -2, and we get 2, and we put those on the number line. We don't really use this other than the factorization is going to help me with my test values. I need to figure out how to shade. -2 and 2 have chopped my number line into 3 regions, over here, in between, and over here. So I will pick -3 because that is in the region to the left of -2 and plug in up here. -3 minus 2 is a negative. -3 plus 2 is a negative. And a negative times a negative is a positive. In between -2 and 2, I'll pick 0. Put 0 in the first parenthesis gives me a negative. 0 in the second gives me a positive. A negative times a positive is a negative. Over here, I'll pick 3. Put 3 in here will give me a positive value. 3 in here gives me a positive value. And a positive times a positive is a positive. And then we use this information to shade. We are looking for greater than. That means we are looking for these regions that have the plus signs on them. So I will shade down here, and I will shade down here. And it is the curved parenthesis because it's only greater. It is not greater than or equal to. And then we just need to write the interval notation for the one on the left is -infinity to -2, union with 2 to infinity. So that is my domain. There's my argument. I need to set that quantity, x plus 5 over x minus 1 greater than 0. A couple of videos ago, we looked at how to solve a rational inequality, and it's very similar to what we just did a second ago. Solve the top equal to 0 gives you negative 5. Solve the bottom equal to 0 gives you 1. Put those numbers on your number line, and be sure you put them in the appropriate place. Negative 5 needs to be to the left of 1. And then we're going to do test values, just like we did a second ago. So in this region, I need something to the left of negative 5. I put negative 6 in here. Negative 6 plus 5 is negative. Negative 6 minus 1 is negative. And a negative divided by a negative is a positive. I will pick 0 between negative 5 and 1. Put 0 in the top is a positive value. Put 0 in the bottom is a negative value. A positive divided by a negative is a negative. To the right of 1, I will choose 2. Put 2 in on the top, and that's a positive value. 2 on the bottom is a positive value. A positive divided by a positive is a positive. We are still looking for greater than, so we are looking for where we have plus signs. So it is this region over here with the parenthesis, this region over here with the parenthesis, which gives me an interval notation from negative infinity to negative 5, union 1 to infinity. Now it asks us to actually find the inverse of an exponential function. To find the inverse of any function, you know the first thing is substitute y in here for f of x, switch x and y, so this becomes x equals 9 to the y minus 8. We want to solve for y, so add 8 to both sides. And the only way to solve this is an exponential function, the only way to solve this is to rewrite it in logarithm form. So this is log base 9 of this quantity, which is x plus 8, equals y. So there is our inverse. There's a logarithm function that is the inverse of that exponential function. Last thing here is a word problem. I know sometimes you look at word problems, especially function word problems, and you get confused, but read this through. Outpatient surgery as a percent of total surgery at hospitals has grown. This is the logarithm function where x is the number of years since 1900. X is the number of years since 1900. It wants us to use the function, use this function, to estimate outpatient surgery as the percent of total surgeries. What that is saying is they want us to find f of x. So this is just a straight calculator problem. Looking for f of x, it equals negative 1,314 plus 303 ln of x. Now what was x? X is the number of years since 1900. So from 1900 up to 1996 is 96 years. Typed it in the calculator exactly as you see, and this comes out to be 69%.